All right. Got the exams. Sent out the announcement. Yeah, there were a couple questions that it was wrong. The key was wrong, so fix those. Those are regraded, so if you haven't gone back and checked your grade, you may see a slight increase. Key should be accessible. The key for all the exams and the quizzes should be accessible. If they're not, please email me so I can go in and check. I believe everything is accessible. We still have the lab practical closes tonight. I didn't check the door if it was open, but you can still go in there and review. Deadline's at 11:30. Make sure you get it done. And then next week we have the final exam. They'll go live on Monday morning. They have to be completed by Wednesday night. Right? Have to be completed by Wednesday night. And then on Thursday I'll check. I'll review answers. Make sure we don't have questions where everyone missed it or nearly everyone missed it. Make sure that everything looks okay. Once I review it, then I'll get the grades up. So right now we have course grades are posted. It's a current course grade that does not have any of the extra credit added to it. So if you donated blood or if you did the sheets, then that's still open until Wednesday. You can still do it. And then our IDEA evaluation, they close today. And I honestly don't know what time they close today, but check it out right now. There it is. Still, 81% is their response rate. 13 hours remaining. Our
How many
targets.
bonus points again?
What's that?
How many bonus points for that again?
4. All right. So I did drop the lowest quiz grade, and I did abide by the syllabus. So if you had the quizzes that were late, the first late one was ignored, and then all the subsequent late ones had a 10 percentage point deduction on the grade. The lab practicals, I plan to drop the lowest lab, or not the practical, I plan to drop the lowest lab quiz. And then for the practicals, it's just, I believe it's 25, 25, 25, and then 20% for the presentation. Everyone did their presentation, all did a pretty good job, so figured 20 out of 20 for that, and then the quizzes, lab quizzes, I think are only like 5% or something like that. Pretty small. We'll get that posted. Remember, lecture is 75%, lab is 25%. All right, so using the current course grade, you can multiply that by 75% and add that to 25% of the lab grade. That gives you your estimate. Now, as far as grade replacement with the final exam, if you do better than your lowest exam grade, one of your lowest exam grades, then I will replace that lowest exam grade with what you received on the final exam, and that excludes any extra credit points that were added. So the extra credit is always going to be added on top of whatever gets replaced. If you do worse, then there is no replacement, but that final exam still counts as 15%. All right. If you have questions, please email. Plan is to review the final exams on Wednesday and try to get the grades posted. I think I have my calculation, my Excel sheet all set, so all I have to do is just transfer the exam grades over and we should be good. We should be good. All right. Any questions? All right, so we have a presentation today. We have Michaela, right? She's going to give a presentation on the parasites of freshwater turtles. I'm just going to turn it over to her, and I would expect a couple questions from this presentation to be on the final. All right?
Okay, so like you said, I am doing parasites of freshwater turtles. This is a Reddit slider if you're not sure what turtles look like. Which button do I push to change the slide?
Arrows left to right. Or you might have to move the cursor onto that slide and then say, just click on it at that point. There you go.
Okay.
And then your arrows will work.
Okay, so the first one is going to be Spirorchis. I think that's how you say it. So this is in the phylum Platyhelminthes, so it is a flatworm. The class is going to be Trematoda. The order is Strigioformes, I think is how you say that. And then the family is Spirochidae. So they are what's known as the blood flukes. They are in the same superfamily as the Schistosoma that we saw in the humans as well. Okay, so some characteristics of it. Here's a picture of what it looks like. They are relatively small, so they're about like 1 to 2 millimeters long. And they do inhibit the heart and the blood vessels surrounding the heart, but also they can go in other organs. So they just flow through the circulatory system and get into the capillaries of different organs as well. And then there is one species, Spirorchis parvus, that actually goes into the central nervous system. So that one can actually get into the brain and cause some damage in there as well. Okay, so a little overview of the life cycle. It is an indirect life cycle, and the definitive host is many species of turtles. I'm pretty sure they're in almost every species that you can find. And then the intermediate host is going to be an aquatic snail. So it's going to be in the genus Helostoma, which are the ram's horn snails. I think we saw those in one of them in class 2. And then here's a little diagram of it. So the adult, like I said, the adult worm is going to be in the heart and then the arterial system, so like the blood vessels. And then the feces are going to be passed on, or the eggs are going to be passed on through the feces in the water. And then after about 5 to 6 days incubation time, they're going to hatch into the merocytium. And then the merocytium are actually going to penetrate into the eye stalks of the snail, which are just those like long little things that the eyeballs sit on top of, if you don't know snails. And then inside the snail, the mother Spirorchis is going to produce daughter Spirorchis. And then after about 30 days inside the snail, the Cercaria are actually going to start getting expelled. They do it in periodics at large amounts at a time as well. And then these Cercaria are going to actually penetrate into the turtle host. So they're going to penetrate in places such as like the oral cavity, eyelids, and also the cloaca. And then after this, once inside the turtle, the life cycle is kind of like splotchy. They're not really sure what happens. So I just have it as maturing worms. And they're just going to migrate via the circulatory system until they make it back into the heart. And then at that point, that's also when they're going to spread out through the circulatory system and go into the other organs as well. And then some of the pathology. So the pathology is mainly associated with the inflammatory response in the migrating eggs, which leads to granuloma formations. So the eggs, like I said, whenever they travel through the capillaries, they're actually going to like get in there and lodge themselves in and kind of block the way. So that's going to lead to a few different things. So at the clinical level, which is just like your observation level, what you can see is lethargy, which is just the turtles not really wanting to do anything. They're just kind of lazy, just kind of chilling. And then they also have the opposite of that, which is constantly swimming. So they just kind of never take a break. They're just always swimming. Also, sideways swimming has been observed, which turtles normally don't exhibit that kind of behavior. And then also there's have been a few cases of hemiplegia, which is just paralysis on one side of the body. And then there's also ulcerative lesions on the carapace and the plastron. So the carapace is the actual like shell part of the turtle, and the plastron is going to be the underside of it as well. And then actually at the necropsy level, so whenever you open it up, you can see subcutaneous edema, which is just like the fluid. And then there's also necrosis of the liver, spleen, and pancreas. And then there can be also eventual death. So there can be secondary infections associated with this parasite as well. It's still associated with the migration of the eggs. And this is more to like the different tissues. And then also continuous GI tract irritation as well. So the symptoms of this are going to include diarrhea, starvation, dehydration, and fluid imbalance. And then in heavy infections, there is even more pronounced endemia in the thoracic and abdominal regions. And then there's also a little bit of decalcification of the shell structure, and then in some other bones as well. And then a little bit more paralysis of the limbs. And then also death follows very soon if in heavy infections. Okay, so this one's kind of not really related to freshwater turtles, but I thought it was cool and it's still kind of associated with this parasite. So this is called Fibropapillomatosis, I think is how you would say that. but it's a fatal disease in sea turtles, actually. And it's in all of them except for the leatherback sea turtle. And this is going to cause external tumors that are going to be like really large, and they're also going to like hang or sag off of the body. So they're going to be like smooth or cauliflower in texture-wise, and then they're all going to have like little spiny projections that come off of them. And this typically forms around the neck, the eyes, and like the base of the flippers on the sea turtles. And the turtles that have this are usually anemic as well. So that's kind of how it relates in with the blood fluke. And then there has been some speculation that Spirorchis could be linked to this disease. They don't think that it's going to be like the direct cause, but they still do think that there is some kind of correlation, mainly because they find Spirorchis eggs inside the dermal capillaries that are actually in the tumors. And then the turtles that do have this disease are more susceptible to get the Spirorchis. So they think there's a little bit of leakage there. And then this is just a picture of what it looks like on a green sea turtle. So you can see like the tumors at the base of the neck, the flippers, and around the eyes. So this is going to impair the mobility and the vision of the sea turtle, which is eventually going to lead to emaciation, which is just like getting really thin and weak, and then also eventual death. It makes it really hard for them to see and swim, so they can't eat, and then they get more susceptible to predation. And immunocompromised turtles are most at risk for this. And this hasn't been observed in freshwater turtles, only in sea turtles. Okay, so the second parasite is Serpinema. So Serpinema is in the phylum Nematoda. The class is Chromadoria, I think. The order is Rabitida. I don't know how to say that. And the family is Camelanidae. So this is also inside the GI tract as well. And then there's two major species that parasitize freshwater turtles. The first one's going to be Serpinema trispinosus, and that's going to be in the Nearctic region, so that's like the North America. And then we have Serpinema microcephalus, which is the Palearctic region, and that's like Europe and Russia over there. So this one is going to be really closely related to the genus Camelanus. Some people even refer to it as a junior synonym. There's been a lot of debate as to whether they're actually like the same genus or not, but this genus has been characterized by a bronze buccal capsule or buccal capsule, so you can see it right here. And then this genus specifically has the presence of the gap that's going to be in between the two sets of the ridges on the buccal capsule. So on here you can kind of see the two different sets, and then you have that one that doesn't have any ridges, the little gap. And then it's also going to be supported by two dorsiventral tridents. So this is a picture I actually took from my turtles. You can see the trident, the three little prongs of it right there. And then the females are going to have three terminal cuticular spikes on them. They are very obvious under the microscope. And then the males are going to have 7 pairs of caudal papillae. So the life cycle of Serpinema is pretty understudied, as it was just taken out from the genus Camelanus. So they have a pretty similar life cycle anyways. It's going to be an indirect life cycle, and the definitive host is in most species of freshwater turtle. So when I was doing my research, I found it in all 3 species that I did. So they're kind of a generalist. And then the intermediate host they use is a copepod, but they can also have parasinic hosts as well. So anarans, which are just like frogs, and then cichlids, pond snails, fish, and damselflies have also been found to be parasinic hosts. So just a little breakdown of the life cycle. The adult's going to live in the small intestine, and it's going to like shed a J1 into the water. The J1 is going to be consumed by a copepod, where it's going to develop to a J3, which is the infective stage. It's going to develop to the hemosyl, or in the hemosyl of the copepod, and then it can do 2 different things. The traditional route is to just go and be straight consumed by a turtle, where the J3 and J4 are going to develop into the intestine, or the small intestine, where it just is going to stay. Or it could be, the copepod could be consumed by a paratinic host, but it's just going to follow the same pathway. So the J3 and the J4 are still going to develop inside the intestine, and then the paratinic host is going to be consumed by the turtle. So the pathology with this is mainly associated with a chronic inflammation. So there's 2 different sites that can have really significant pathology. The first one is the small intestine. So the small intestine, which is where the adult worms reside, is really caused by the infiltration of the inflammatory cell response. And so the symptoms of this are going to include edema and then hyperemia, which is just like the inflow of excessive amounts of blood to the area. And you can also have intestinal wall thickening, as well as hyperplasia of the mucosal glands. So that's just like the enlargement of them, so they just get really big and inflated. And then mucosal ulceration, and then also intestinal mucosal exudation, which is just like the mucosal linings just kind of like leaking off. And then also the worms have been known to go and migrate into the pancreas. So in the pancreas, it results in a mild infiltration of the eosinophils, and those are just white blood cells that really respond to parasitic infections, and then also lymphocytes. And these symptoms include fibrosis, edema, and necrosis. So the death in this, or the death associated with Serpinema, is pretty rare, but it can occur if you have heavy infections, and it's normally a result of the necrosis of the pancreas. Right, so then we're going to have Spiroxys. So this is also a nematode. It's in the same class as the other one, so the class Chromidia. The order is Spirochis, and the family is Spirorchidae. This is also an inhabitor of the GI tract as well. So the morphology of this is pretty distinctive. It has an oral opening surrounded by two lateral trilobed lips. So this is also a photo that I took. You can see just one side of it, so you can see the three distinctive lobes right there. The tails on both these sexes are going to be conical and sharply pointed. It's like a little pin needle. They're really sharp. And then the females are going to be bigger, so they're going to be like 30 to 43 millimeters long. The males are going to be a little bit smaller, so they're 20 to 28 millimeters long. And they're going to have 11 pairs of caudal papillae on them as well. So the life cycle for this one is also going to be indirect. So the host for this is mainly going to be spiny softshell turtles. I only found them in my spiny softshell turtles when I was doing my research, so I didn't find them in anything else. But there was some reports of them in other pond turtles, so like sliders and stuff. We just didn't see them here. And then the first intermediate host is going to be a cyclops, so it's like a little invertebrate. And then it also has a second intermediate host. Those are going to be mud minnows, mainly tadpoles, and that's frogs and salamander tadpoles, and then also dragonfly nymphs as well. So a little breakdown of their life cycle. The adults are going to live in the stomach mucosa of the turtle, and the eggs are going to be passed through the feces into the water. The eggs hatch in about 1 week after incubation in the water, where they hatch into a J1. And the J1 is actually going to attach onto vegetation, and it's going to actively vibrate to try to get the attention of copepods just so they can be consumed faster. So that's like a way to help them transmit the life cycle. And then once the cyclops actually ingest the J1, they're going to be in the body cavity, and they're going to molt into the J3. And then the tadpoles are actually going to consume the cyclops, and the J3s are going to insist inside of the tadpoles into the mesenteries of the small intestine. So then the tadpoles are going to be consumed by the turtle, and then they're going to molt into the J4 and then molt into an adult where they reside still in the small intestine. So the pathology associated with this is mainly granulomas. So mature granulomas are surrounded by fibrosis capsules, which is just fibrosis. And then there's also lesions in the gut mucosa that are associated with the attachments. And then there also can be some pathology with the larval stages. So this is more associated with accidental consumption. So like if a turtle accidentally eats a cyclops that hasn't had it fully developed to a J3 or something like that. This is going to cause gastric granulomas, and the symptoms are going to be reduced appetite leading to wasting. And then if a younger turtle consumes one of these, they're going to present stunted growth as well. And then this is just a picture of one of the granulomas in the gastric mucosa, so you can kind of see it like right here. They do contain macrophages and as well as really giant nucleated cells. All right, so then we're going to move on to the acanthocephalans. So we have Neochinorhynchus. Phylum is Acanthocephala. The class is going to be Eocanthocephala, and the order is Neochinorhynchida, and the family is Neochinorhynchidae. So there's 3 major species that are going to infect turtles in the U.S., and I found all 3 of these species in my turtles as well. So the first one is going to be Neochinorhynchus emetoides, I think is how you say that. So that's going to be in the continental U.S., but it's also going to go down into Mexico as well. And then you have Neochinorhynchus ammoides, which is just going to be in the continental U.S. And then you also have Neochinorhynchus pseudomyoides, which is just also in the continental U.S. And it's, I think it's on the next slide. Okay, so the morphology. So it's going to have a globular proboscis with 3 circlets of 6 hooks each. So I don't know if you can actually see it on this, but this is the best picture that I had. But you can see like just the 2 little hooks like right here at the very top. And they are going to have 6 subcuticular nuclei. 5 of them are going to be mid-dorsal, and 1 is going to be in the mid-ventral line, which is near the anterior end. And then the cement gland in males has a singular cylindrical mass, typically with 8 large nuclei. And then the life cycle of this one is also going to be indirect. And then this is going to affect most of the turtles in the family Entamoeba, which is just like your pond turtles, so your sliders, your river cooters, those kind of turtles. And then the intermediate host is going to be an ostracod, and they can also have paratenic hosts, which has been found to be aquatic snails as well. So the life cycle of this one is actually pretty simple. So the adults are going to live in the small intestine of the turtle. They're going to be passed with the feces, or the eggs are going to be passed with the feces. They're going to be consumed by one of the ostracods, and then the ostracod is going to have the development from the acanther to the acanthella to the cystocant, and all of that is just going to be inside the gut of the ostracod. And then after about 21 days, the adults are going to consume the ostracod. Adult turtles, that is. So the pathology for this one, the epithelial damage and hemorrhaging at the site of attachment. So this is just a picture of, this is not my picture, but this is one of the small intestines. This is just like a huge mass of Neochinorhynchus. I think they said it was a mixture of 2 different species, so it's not just one, but that just shows you like how prevalent some of these worms can be. And I did find a huge mass like that in one of my turtles, but it wasn't that extensive. But this causes destruction of the gut mucosa, the lamina propria, muscle layers, and serosa, which leads to perforation. And then you can also have localized inflammation by the trunk of the worm when it's in the intestinal lumen as well. And then I guess it has a penny here just so you can see like they're not very big. They're pretty small parasites as well. And then we'll move on to the amoebozoa. So this one is Entamoeba invadens. So this is phylum Amoebozoa. The class is Lobacea, and the family is Entamoebidae. This is also an inhibitor of the GI tract. So the morphology for this one, it's going to have 2 different stages. So we're going to have a trophozoite and a cyst. The trophozoite is going to have a circular nucleus, and it has no chromatid bars present. So on this side, this is going to be your trophozoite, and then over here is going to be your cyst. So your cyst is the one that's going to have the cyst wall, and it's also going to have the chromatid bars as well. So the life cycle for this one is going to be a direct life cycle, so it doesn't have any intermediate host or anything. And it's also really similar to the amoeba that we find in humans, or the one that we went over in class as well. So the transmission is also going to be fecal-oral, and the hosts are commonly box turtles, but other species have been observed as well, but mainly it's just the variety of box turtles that gets infected with this. And then the trophozoites are going to replicate using binary fission, and the cyst stage is going to be the infective stage in these. So the life cycle for this one, we'll just start out with your trophozoite that's going to be in the small intestine. It's going to replicate by binary fission, and it can either do 2 things. It can go on to form a precyst, or it can actually penetrate other organs and then replicate inside of there. And it's going to start a whole new life cycle in that different organ. But if you go down this way, you can have the precyst, and then you can have the young cyst divide into the cyst, which divides again into your metacyst, which is then going to be passed on through the feces into the environment, and then you're going to have your turtle consume the metacyst again, and you're going to turn it into 8 metacystic trophozoites, which then transform into your trophozoite in the small intestine. So it's like almost identical to the one that we find in humans. So the pathology with this one, mainly you can see watery, bloody, or mucodal diarrhea. There's also a lot of anorexia, dehydration, lethargy again, as well as emaciation, which is usually accompanied with secondary bacterial or fungal infections as well. So you can have lesions in the liver and the intestinal tract, which is kind of what this is. So this is like really messed up intestinal tract, but you can just see how the necrosis of it is just not good. This is going to cause erosion, inflammation, and also ulceration as well. And then trophozoite penetration in the GI wall can also have a different pathology. That's going to cause a thickening of the intestinal mucosa. And then the trophozoites, like I said, they can migrate to different organs as well. So in there, they're going to have a little bit of pathology too. If it goes to the spleen, it's going to have the splenomegaly, however you say that. Kidney abscesses can form, as well as liver abscess formation, which is known as hepatic amoebiasis. And then that's going to be due to necrosis. So death occurs quickly if a turtle is infected with this, usually within a few days to up to a week, and they survive with it. And that's if it has a really heavy infection. And then I think this is my last one. Nyctotherus is going to be a ciliate, so it's in the phylum Celophora, in the class Armophoria. Order is Metopida, and then the family is Nyctotheridae. So this is also going to be an inhibitor of the GI tract as well. There is a similar species that occurs in humans. It's called Balantidium. I guess I say that. It's a really close related species, so their life cycles are going to be really close, their morphology is really close, and their pathology is going to be very similar as well. So the characteristics of it, here's a little picture of it. So it is large and kind of lemon-shaped. So you can imagine that looking like a lemon. And then they are active, but they move very slow. And they do, or they are covered in cilia, so that's going to be their main form of movement, or their only form of movement. And then the life cycle of this is also going to be a direct life cycle. And they do have many definitive hosts. So there's many species of turtles, but they're also pretty common in tortoises as well. I think they're a little bit more common in tortoises than freshwater turtles. And then once again, the trophozoites are going to replicate via binary fission. And then the cyst stage is also going to be the infective stage in here as well. And then a breakdown of the life cycle. So the trophozoites, they're going to be in the lumen of the large intestine, and they're going to be replicating by binary fission. And then once again, those trophozoites can do two things. They can either migrate to the colon, where they're going to replicate via binary fission, or they could form a precyst. And then the precysts are going to form the young cyst, and the cyst, metacyst. And then the metacyst is going to be passed on through the feces, and then ingested again by the turtle. And it's going to go into the small intestine and then migrate to the lumen of the large intestine. And then the pathology for this one is this specific parasite is actually considered a natural inhabitant of the gastrointestinal tract of most turtles. So it aids in the digestion of cellulose. So normally it doesn't have any significant pathology. It's actually helpful for them, but in some cases, if they do acquire a large amount, that's whenever you start to have some issues. So this can cause significant and severe irritation of the intestinal wall. And you can have two different phases of this. The first one is going to be your acute phase, and that's going to just have acute diarrhea, which is going to result in dehydration and a little bit of weight loss. And then if you leave it untreated and they keep on acquiring more in the infection, you can move into the chronic stage. So the chronic phase is going to result in a complete loss of normal digestive tract fauna. So everything that you had in there before is going to be eliminated, including this parasite's just going to like take over. And then it's also going to result in initiation as a result of the inability to digest and metabolize food. So that just means the turtles aren't digesting their food, so they're just like passing it as full, undigested whenever they're in their stool. So that's like a key factor in noticing that you have this parasite. And then that's it.
Questions?
Did you notice any like specific parasite that was most common among all of these that you found in the turtles?
In my turtles, the Neochinorhynchus was definitely, and then second was going to be the Serpinema trispinosis. The Neochinorhynchus had more like abundancy, but I saw Serpinema in every single turtle, whereas the soft shells didn't have Neochinorhynchus.
Other question? Any snappers? No.
How did you get your turtles?
So my turtles were donated from the Texas Parks and Wildlife. They were like accidental captures during one of their fish surveys. So they just kind of donated them to me. But we did some trapping, but haven't caught anything. Yes.
How many turtles did you end up looking through?
So only 11. Yeah.
How many sea turtles?
I've done 2. Yeah. And I've done 1 tortoise, so there's a little variety going on.
All right, any other questions? Nope. All right, good job. All right. Let's hit the lights back there, please. All right, so I'm sure I'll get asked a question about how to calculate my grade. Let me show you. So right now we have 85% for our course grade. All right, so what you can do is take your course grade, All right, whatever the course grade is, go ahead and multiply that by 85. 85%. All right, that's going to give you how many points you currently have, plus what you would do is take your final grade, take your final exam, and multiply that by 0.15. And that would give you an estimate of what the course grade would be. All right, not the course grade, the lecture part grade. I should change this instead of course grade, lecture grade. To lecture grade. All right, lecture grade, and then what you have is your lecture grade, whatever you calculate, multiply that by 85%, or 75%, 75 to 25, 0.75, plus your lab grade, that's 25%. And that would give you your overall course grade. Course grade gets recorded as letter grades. So you can kind of how you can work it out. The exams are posted, your exam grades. So remember, like exam 1, exam 2, exam 3, I just add the parts together, right, to get your grade. The life cycle parts, though, had, let's say, 40 questions. All right, it's reported in Blackboard as 40 questions. All right, but it was only at 30 points. I think exam 3 was had 50 questions, but it was only at 40 points. So what I do then in my grade book is to take the score. If you scored 40 or higher, then you got a 40 out of 40. If you scored less than that, then you have that score. So don't think that, hey, I calculated a different lecture grade. Well, if you had 49 out of 50, you didn't get those like extra 9 points added to your lecture grade. So that's how you can kind of calculate it yourself. Once I do have the grades, I can easily calculate it. What you'll probably see is that the final exam has minimal effect on your actual lecture grade. Right? It's only out of 15 points.
Unless you get that replacement, right?
Unless you get the replacement. Yep. So kind of what we see if you're sitting at, let's say, I don't know, I think most common ones tend to be like 85%, right? We can, let's open up, calculate. What is this? MS resource admin. Jeez, man, is that massive? You're gonna see this. Look at the size of that thing. There we go. All right, so what grade did I say? 85?
85.
All right, so you're right at 85 times 0.85. All right, so 72 out of 85, that's what you currently have. And then you have the final exam. A lot of times I get asked, what do I need? I just need to get a B. All right, so you're at 72.25 right now. We've got 15 points on the final exam to get. How many points do we need to get to that 80? 7.75. So that's what you need, right? So you need 7.75. It's out of 15 points. You could get a 51%, 52% and still maintain B. And you would say, holy cow, that's, I didn't expect that. Well, it's only out of 15%. It's a small percentage. And I do that because we do tend to have a lot of questions. It's a lot of material, right? Think about all the disease names that we've had. All right. And yes, I will take all the possible parasites and put them on one massive list. So you have to pick which one. It's rough. Now, you do have the potential. So the final exam, less likely to hurt you, but you could do significant improvement. So if you had, let's say, 80% on exam 1 and exam 3, but on exam 2 it conflicted with, let's say, organic chemistry or biochems in the fall, right? Yeah, organic chemistry, and maybe cell bio on the same day. You're like, oh man, I just blew it off, and you got a 60%. Well, that second exam is worth 25% of your grade. All right, so just to kind of demonstrate, if you had a 65%, and that's out of 25 points, you basically lost 9 points total off your overall grade. If you replace that with, let's say, an 80 on the final exam, all right, you got an 80 on the final exam, you've just brought that grade up by 4 points. So that's, going from, let's say, an 86 up to an A could be significant. And if you have questions, feel free to email me. All right. Typically don't do these online exams. The only one that I have for comparison is the ecology class. And yes, the ecology lecture exams were pretty good. The number of grade replacements were actually a lot lower than what normally happens with the regular written exam. And I don't know if that's because grades were much higher than they typically are, or if it was the exam was a lot harder. My guess is that the grades are better. The overall grades for this class are better than in years past, but you also didn't have to draw the life cycles. All right. If you don't have questions, we're done. You did miss out. We had 2 weeks where we lost. We would have covered the pentastomes, which you probably see. We didn't cover the nematomorphs, which are pretty cool. And we didn't talk about the ecology and stuff and mix of transmission and treatment stuff. That's in your textbook. All right. Good luck. Good luck studying. Final goes live on Monday. We'll have until the end of Wednesday to do it. Yep.
Don't put that paper on.
All right. I'll wait here for you.